Hey everyone, welcome to assignment 20. In assignment 20, we're going to be looking at tangent, cotangent, secant, cosecant again, and maybe one or two other things. So why don't we start just by making sure everyone's comfortable with graphing these four trig problems, four trig functions. So will you please do number one, y equals 1/3 tangent 2x minus pi over 4 plus 5/3. Ooh, and what is it that for tangent we set the argument equal to? We know it's not 0 to 2 pi. What is it? Well, if you don't know, look it up in your notes from assignment 19's video. But certainly if you use the wrong, if you set this argument equal to the wrong values, the whole rest of the problem is going to be wrong. So that's really something terribly important for us to make sure we know going into an assessment on this. Okay, did you find it? So we want to set the argument equal to negative pi over 2 and positive pi over 2. Okay, so this is where we have those vertical asymptotes. So we want to find out where our vertical asymptotes are. Okay, pause the video, give it a try, see if you can come up with the right graph. I think that would be fabulous if you did. Well, when you come back, we'll finish. Okay, so I'm adding pi over 4 to negative 2 pi over 4. That's going to get me 2x equals negative pi over 4. And when I divide by 2, I get x equals negative pi over 8. And here, when I add pi over 4 to pi over 2, which is also 2 pi over 4, I get 2 pi over 4 plus 1 pi over 4 is 3 pi over 4. And then I'm going to divide both sides by 2. So I get x equals 3 pi over 8. 3 pi over 8, negative pi over 8. Those are our vertical asymptotes. So x equals negative pi over 8 and 3 pi over 8. So negative pi over 8, 3 pi over 8. Halfway between these, we have our inflection point, where we go from concave down to concave up for positive tangent, or concave up to concave down for negative tangent. This is positive tangent, so I know that shape, but what can I say about where this ordered pair is? Well, halfway between negative 1 pi and positive 3 pi, I add them together and I double the denominator. Yes, I know there are pi's still there. This is going to be 2 pi over 16, which reduces to 1 pi over 8. So pi over 8, comma, and that's the y value. We've shifted this graph up 5/3. So this 0, 0 point now becomes pi over 8 5/3. And all that's left for us to do is sketch in our graph. That's right, because we're not using quarter points, we don't have to worry about that amplitude. We do have to check to see if there's a positive or negative sign here. Since we have positive, we have this shape. If there had been a negative here, we'd have this shape. Okay? There's number 1. How about number 2? Y equals 7 cotangent x over 3 plus pi over 6 plus 12. Okay? Give that one a try. Ooh, what is it that we use here to set the argument equal to? Is it negative pi over 2 to pi over 2 like it was for tangent? No. That's great that you remembered that. What is it instead? So for cotangent, we set the argument x over 3 plus pi over 6 equal to 0, but not 2 pi. X over 3 plus pi over 6 equal to pi. The period for cotangent is pi, so we have to go from the start of the period to the end of the period. Okay, we solve each of these. and I multiply both sides by 3, negative pi over 2. And here, this is 6 pi over 6 minus 1 pi over 6 is 5 pi over 6. And if I multiply by 3, I get x equals 5 pi over 2. Negative pi over 2, 5 pi over 2. That's where our vertical asymptotes are. Negative pi over 2, 5 pi over 2. Halfway between, we have our inflection point. So negative 1 pi plus 5 pi, and double the denominator. So that's going to be 4 pi over 4. I guess 2 pi over 2 is one way I could write it. I mean, I could just write it as pi. But somehow that 2 pi over 2, because of these, sounds really good to me. But I'm going to go with the more simplified pi. So the angle is pi. And what about the y value? Well, there's our d value. We shifted the whole graph up 12 places. So that's going to be a 12. Finally, what about the shape? Well, that's cotangent, not tangent. Tangent would look like this. Cotangent looks like this. Okay? Okay. Yeah, that's it. That's all we need. 2 vertical asymptotes and an inflection point. That x value is halfway between these vertical asymptotes. Okay. Y equals negative 2 tangent pi x minus pi over 3 minus 5. Please graph that. Hey, welcome back, everyone. So, did you set pi x minus pi over 3 equal to negative pi over 2? And pi x minus pi over 3 equals positive pi over 2? I hope so, because that's what we need to do. If not, you might want to pause the video now, make some notes in your notebook about this, and actually correct the mistake and see where things were supposed to land. Okay? Give that a try. So this is 3 pi over 6 minus 3 pi over 6 plus 2 pi over 6 is going to be pi x equals minus 1 pi over 6. And if we divide both sides by pi, we get x equals negative 1/6. Here, I have 3 pi over 6 plus 2 pi over 6. That means I'm going to get 5 pi over 6. And if I divide by pi, I get x equals 5/6. Okay, so I have vertical asymptote here at negative 1/6. Here at 5/6, I have a vertical asymptote. And then I'm doing negative tangent. Is this negative tangent? No, this is regular tangent. Negative tangent looks like that. And this inflection point is located where? That's the y value, sure. What about the angle? What about this x value? What are we looking for there? Well, I want halfway in between these. So negative 1 plus 5 is 4, double the denominator. So 4 over 12, which could reduce to 2 over 6, or 1 over 3. And there we go. There's our graph. No need to worry about quarter points. Yeah, that's it. Okay, how about this one? Y equals negative 1/2 cotangent pi over 2, whoa, minus cscx plus 5/2. Okay. I look forward to seeing your graph of cotangent. Give it a try. Hey, welcome back. So what did you set the argument equal to for cotangent? Did you use pi over 2 and negative pi over 2? I hope not, because that would be wrong on an assessment. Well, and always, not just on an assessment. So I'm going to take pi over 2 minus pi over 3x and set that equal to 0. And pi over 2 minus pi over 3x equal to pi. The period for cotangent is pi, so the distance between these is pi. Excellent. Now, what can we do next? Well, I like the idea of solving here. I'm going to subtract pi over 2 from both sides, and then multiply both sides by negative 3 over pi. That will allow me to cancel and cancel and get pi by itself. So here the pi's cancel. Negative times negative is positive, and I get x equals 3/2. Okay, what about this equation? Well, I'm subtracting pi over 2. 2 pi over 2 minus 1 pi over 2 is 1 pi over 2. And then I'm going to multiply both sides by 3 over pi. And that gives me x equals negative 3/2. Well, that's pretty straightforward. We've got negative 3/2, and we've got positive 3/2. Now what? Well, it's a negative cotangent. So does it look like this? No, that's regular cotangent or negative tangent. Negative cotangent looks like this. And we do have an inflection point. Halfway between negative 3/2 and positive 3/2 is 0. But what do we use for the y value? Yes, it's right here. Our d value goes there. And that's us being done with problem number 4. So I think that's all that there is to be said about tangent and cotangent. Could we do something maybe to review secant and cosecant? How about